Welcome everybody to my talk on evaluating the accuracy of cloud natural language processing services using ground truth experiments. My name is Frank Pallas, and the work behind this talk was done together with Dimitri Stauffer and Jörn Kuhlenkamp, and we are from the Information Systems Engineering Group at TU Berlin. Natural language processing, or as some phrases, natural language understanding, is a core functionality behind a multitude of modern intelligent applications. For instance, we use sentiment analysis for the purpose of social media analysis with regard to brand monitoring or competitor monitoring. So when we want to understand how the public sentiment about McDonald's increased or decreased at a certain incident. We use named entity recognition to implement tailored customer support or chatbots or so. So when we want to recognize a certain city within a chatbot to direct a customer to the appropriate person, or we use text classification to automatically group documents in thematic groups or so. For implementing such NLP functionality, we can basically follow two different approaches. First, we can use established libraries and toolkits and frameworks and so forth like SPACY, GATE, NLTK, and so on. And second, we can use cloud services provided by major providers such as IBM, Amazon, Google, or Microsoft. Both have their pros and cons, but especially cloud services have a couple of benefits with regard to the upfront costs that you have to take, or to the scalability, allowing you to just process large amounts of natural language data once a month or so. And their functional capabilities are, in most cases, good enough for what you actually need. So cloud-based natural language processing services are a thing, and therefore we will concentrate on those herein. When having to choose between different providers for cloud NLP services, we have to answer a couple of questions. In particular, it is very interesting how good, in matters of the achieved accuracy and so the correctness of results, how good are those cloud services provided by Google, Amazon, IBM, and Microsoft for the major NLP tasks. And here we are particularly looking at sentiment analysis, named entity recognition, and text classification. In addition, we want to know what hidden factors possibly influence those accuracies and how they influence them. And to a certain extent, we are, of course, also interested in the cost and the latencies that are to be expected. In answering these questions, we are building upon two different strands of related work and existing research. I will not go into the details here, so if that is of interest, please refer to the paper, but basically these domains are the experiment-driven evaluation of cloud services from a black box cloud user perspective, and on the other hand, the experiment-driven evaluation of traditional non-cloud NLP applications. And what we're doing is we're taking the best from both worlds and bring them together into an own experiment approach, particularly tailored to the needs that we have with regard to cloud-based NLP services. And this is the first thing. The approach that we are taking in our research is an experimentation approach. It follows a very common setting. So we have a cloud NLP service, which is a service under test that we are evaluating. We have an experiment client, which actually executes the experiments. And in order to do so, we need some sort of ground truth data. So ground truth data is always a combination of some sample text that is a representative input for the respective service and a reference result, so which is the perfect output, which the most accurate output that we can imagine that the certain service under test should provide. And we take this ground truth data as an input to our experiment client, and then the experiment client does a request for every piece of sample text in the ground truth data to the cloud NLP service. It then gets a response, which we call the observed result, so the response from the service. And then we compare this observed result with our reference result, and by comparing them, we can generate a certain distance metric that actually fits what we want to know and what we are experimenting about. And this distance metric, in the end, describes the accuracy that is provided by the particular service. So that is our general approach. And of course, the question is, where do we get this ground truth data from, and how do we create that ground truth data? There are, of course, some requirements that these ground truth data must fulfill, but I will not go into the details herein. If they are of interest to you, please have a look at the paper. So these are the requirements for ground truth data, and based on these requirements, we explicitly decided to follow an approach of implicit crowdsourcing instead of using professionally pre-annotated reference data sets like the Wikigold corpus or the Reuters corpora and so on. Basically, this allows us to fulfill the requirements way better, and how this approach of implicit crowdsourcing, which is basically just harnessing what's already out there, how this approach works shall be illustrated based on the first case of sentiment analysis. Here we used the existing Yelp open data set, which is basically a data set about reviews for hotels as well as for other kinds of companies. And I just have an example here of the Four Seasons Hotel in Philadelphia, where you see a text of the review as well as a star rating ranging from 1 to 5 stars. So what we did with this data set is we extracted the sample text from each review and the star rating. The text, the sample text is basically the review text, and the star rating is our reference result. And based on this ground truth data, we can analyze sentiment analysis services, because we already have the correct sentiment that is expressed in the text materialized in the star rating. And what we then do with this ground truth data set in our experiment is we put that sample text into a cloud sentiment analysis service of one of the 4 big providers. And then we get the result for the sentiment back. Different providers report their sentiment analysis results in different ways. So therefore, we have to normalize them to the respective star rating that we have in our reference results. And then we just compare the result provided by the cloud service with the reference result that we have in our ground truth data. And from that, we calculate the absolute polarity offset for each sample, and based on that, we can do our analysis. And we also do some sort of, exploratory analysis with regard to additional factors like, does the star rating actually affect how good the responses are, and so on. So what were the results that we got? The generalized aggregated results are shown here on the left-hand side. We basically find that AWS has the lowest median offset, which is better. So a low offset is, of course, a better result. IBM has the most consistent offsets, but basically the overall accuracies between those 4 services do not differ too much. When we look at the details, however, some interesting things emerge. When we do an in-depth analysis, depending on the actual star rating that has been given in our ground truth data, we see that Google performs significantly better for reviews that have a 3-star rating than it does for reviews that have a 1 or a 5-star rating. So Google performs significantly better for rather mediocre reviews, whereas AWS and to a certain extent also Microsoft perform way better for extreme reviews. So they have quite good results for reviews with 1 and with 5 stars, and a more significant offset for 3-star reviews. So when we look at the distribution of the average polarity offset provided by the different cloud providers, we would expect something like this. What we actually got was a distribution like this. So IBM and Microsoft's offset distribution looks quite close to what we would expect. The Google offsets are obviously rather stepwise, but that's also not so far from what we would expect. AWS, however, very often provides offsets that are quite close, but not exactly, but quite close to whole numbers. So AWS very often provides results like 3.99 or 2.02 in their sentiment analysis service. This does, of course, raise the question whether AWS somehow recognizes the text as being from a product review and therefore having to represent a whole number sentiment or so. And if this is actually the case, there is a follow-up question whether this is the case by accident or by intention. So if there is an AWS NLP engineer in the audience, I would be happy to discuss those results. Yeah, quite interesting finding. So now let's briefly look at named entity recognition. Basically, in named entity recognition, we followed the ground truth generation approach of search-based indirection of reference results. In this approach, in general, we start with a substantial set of entities considered relevant and assume those entities to be the reference results. We then feed each of those entities into a search engine, which is our approach for indirection. And then we use the search results as input data within which the reference result is to be recognized as named entity. So what we did in this particular case concretely, we took trending Wikipedia articles by the scanning edit date from those categories that are covered by all named entity recognition services. In particular, Wikipedia articles referring to persons, to locations, and to organizations. For instance, we use the person Hugh Jackman here. We then feed this article's title into a Google News search, get, of course, results from Google News, and there we take the first 100 results for each reference result, split it up into sentences, and keep those sentences that contain the original title. So in this case, it could be a sample text like big screen movie stars Chris Hemsworth and Hugh Jackman are headlining, and so on and so on. And there we have our ground truth data set. Based on that ground truth data set, we then execute our experiment. So we feed the sample text into the cloud named entity recognition service. Then we get a response comprising the recognized entities and categories like Chris Hemsworth and is a person, is recognized as a person. Hugh Jackman is recognized as a person, and so on. And then we compare those results with our reference results and again generate several accuracy metrics per entity and per category, like the accuracy for persons, the accuracy for locations, and so on. For details on this, please have a look at the paper. But what we basically can report is that distinguishing between something we call exactly correct recognition and a completely unknown entities, we can say that basically all providers know persons significantly better than locations and organizations. Google provides the best results for persons and locations, whereas Amazon provides the best results for organizations. When we look at those entities that are completely unknown by the respective providers, so even when you search for them multiple times, we get a sort of inverted result, confirming the finding from the exactly correct recognition. Again, Google misses the fewest persons and the fewest locations, whereas Amazon misses the fewest organizations. So basically, we can say that different providers have a different fitting for different categories of named entities. And then finally, we come to the NLP task of text classification. For gathering ground truth data in the context of text classification, we use a comparable approach of indirection. We start with a list of categories that the two providers offering text classification, namely Google and IBM, provide us. We take this list of categories, generate a hashtag from that, query the Twitter API for tweets that contain an external URL, and when this external URL points to a news or a blog entry, we scrape that plain text, and in the end, we end up with a ground truth data set that contains news or blog text that were hashtagged on Twitter with the particular reference category that the cloud provider uses. This is then again put into the experiment in the same way we did for the others. Here we are calculating the level 0 accuracy as well as the level 1+ accuracy to have two different measures. And what we come up with as results is depicted here. Again, we have quite comparable results across the different providers. However, there are some things that are interesting. In particular, Google is way better than the other providers for science-related text, for classifying science and identifying science-related text as belonging to a science-related category. When wanting to explain that, it might be the case that the text classification service by Google is profiting from Google's activities in the field of Google Scholar, and therefore it can better classify science-related text correctly. IBM, in turn, is significantly better for health and fitness-related categories, and here a possible explanation might be that IBM profits here from the efforts that they put into Watson Health. So therefore, they are better capable of recognizing and correctly classifying health-related text. So these are the results for text classification. We also have some interesting insights and finding on additional aspects, in particular on cost and latencies. I will skip them here due to time constraints. And for that, please see the paper. Coming to the roundup, in this talk, I presented a novel approach for evaluating cloud natural language processing services accuracy that is based on implicit crowdsourcing of ground truth data, especially using search-based indirection of reference results. We applied our novel approach to sentiment analysis, named entity recognition, and text classification services that are offered by Google, Amazon, IBM, and Microsoft. And those experiments provided unforeseen insights that are of direct practical relevance when, for instance, you have to choose the provider that you want to use in your application based on the use case. So when you have a use case that will probably require good recognition of extreme sentiments, then you will probably have to choose a different provider than it is the case for rather mediocre reviews. You may also want to choose your cloud provider, your cloud NLP provider, based on the categories of named entities that are to be recognized, the domain of text that is to be classified, and of course the cost and the latency requirements that your application has. So in all these dimensions, our experiments provide unforeseen and practically relevant insight. To the best of our knowledge, we herein presented the first structured, experiment-driven accuracy evaluation of cloud NLP services. And nonetheless, there is a lot of more work to be done. So far, we did not look at specialized providers. There are some providers that are actually specializing on an NLP task. These have not been covered yet. There is, of course, replication necessary with other data sets to validate our results. Of course, we can think of repeated reruns of the same experiments to track improvements of the different services, and so on and so on. So there's a lot more work to be done, and I'm happy to talk about that in the Q&A session. But for the moment, that's it with my talk. Thanks for watching, thanks for listening, and now I'm awaiting your questions.